Yeah, good day, everyone. I will start in some minutes. Just wait for some minutes for my to join. Good day. Yeah, not to waste any more time waiting for people. Good day. My name is Nemeka. I'm a data scientist at Hamuya Lab, and today I'll be like introducing the whole like Gen AI course. Today will most likely not be all about coding for now, right? And mathematics that some people are complaining about, but it will be most likely just an introduction, a lot of definitions, a lot of like understanding what the terms are, right? You know, many of us here might not be familiar with um, generative AI or NLP or LLMs and all of that. And so today I'll just within 1 hour, right, try to introduce all of that. Then next week, that'll be by Monday, we're going to actual coding, right? Uh, Try to do some code and maybe some mathematics, maybe just maybe. We see from there. Right? So let me share my screen. And if you have any questions, please, you can type it in the chat. Um, so hope my screen is visible.
Yes.
All right, thanks. Share, share, slideshow. So good day to week one of is it week one? Yeah, first session to introduction to generative AI. Right, it's good to have you here. I see some familiar faces from the data science track and data engineering track. It's nice to see you all trying to develop yourself, get yourself better. Yeah, and what will we be covering in this introduction? Oh, in like in the whole week one or stage A, right? It will be all of the theory, right? By stage B, sorry, you will most likely be writing real code, right? Actual real code using some frameworks and all of that. Um, so yeah, let's get to it. Let's get to it. I know most of you have read the materials, and some of you are saying that it's quite bulky and um, and maybe not mathematical enough for him or her. Um, it's that we don't want to push many of you away with mathematics, right? This course is to get you um what's the name? Okay. All right. So can't hear me. Can somebody said can't hear me? Can you hear me? Choma said she can't hear me. Can you hear me clearly? Choma, you sure it's not your network? Okay. Am I audible?
Yes, you are. Go on.
All right. Thank you. Thank you. I don't know. Choma, maybe you should go fix your earpiece or something. All right. So now, like I said, it's definitions. I know most of you are from a background of data science and you've done some deep learning stuff. So let me not bore you, but we all know what machine learning is, right? You all know that in machine learning, you have data, right? You have data and you want to use that data to build a model, right? You want to get something automated, right? So you have data, you do some feature engineering, data processing, right? You choose a model you want to use based on the data structure, the data quality, distribution, whatnot, and what you want to achieve, right? Like random forest, decision tree, gradient boosting, XGBoost, blah, 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 right? We all know what machine learning is. So we are going maybe a step further, right? The thing about Gen AI is that it's most likely a combination, it builds on top of each other, right? And yeah, it's a step-by-step stuff. To get to deep to generative AI, you need like data, right? You need data, you need to do something to that data, right? You can't just, but yeah, like we'll get to that. And we know what deep learning is, right? Sometimes it's good to really clarify. Someone doesn't know what difference between AI, ML, DL, Gen AI, all of that, right? They all have definitions. They're not just random names given, right? Computer vision, right? These are all terms that actually have meaning. So yeah, when you get to something like deep learning, deep learning has to do with artificial neural networks. That's it. Deep learning is ANN neural networks, right? And there are different neural networks. There are different shapes and characteristics of neural networks. We have just the let me should I try? We have the I'm sorry that these slides are not that innovative, but by the next session we'll get to real code. I know many of you want to get into real code, but let's just be the step by step, right? So deep learning, you have neural networks like fully connected neural networks, right? You have the LSTMs, RNNs, those are neural networks too. We have the CNNs too, convolutional neural networks. I wish I don't know why I didn't add this here. So yeah, all of these are used to learn complex patterns. And I hope we what do you call it? The requirement or prerequisite for generative AI is that you know sufficient ML, DL theory. I know some of you are waiting for mathematics that will blow your minds. That it's the magic that's one going, but we are expecting you to know some things, right? And we expect you to know what um, the training that goes on, right? The loss functions in deep learning, the optimizer, the batch sizes and all of that, right? what they actually do. We can't do that from here. Like you get, it's going to be so long. It's going to take a lot of time. So that's why we jumped ahead, right? So if you don't know deep learning, go and do some refresher on deep learning, right? You might not really need it, right? You might not really need it because there are many people in the field of Gen AI that don't really know what's happening in depth, right? And they are still AI engineers or LLM engineers, but you cannot be a scientist and not know what's going on. So yeah, let me continue. So generative models, let me check the charts. We get this presentation. Oh, definitely, definitely. You get it. Okay, generative models. I hope like so. Let me just give you a breakdown. Right? There is the supervised machine learning. There is the unsupervised like the clustering algorithms and principal components analysis. So that was a PCA. We have the hierarchical clustering and all of that. So those are all unsupervised, right? You don't have labels, right? But there's now something called self-supervised, and yeah. So self-supervised means that the model itself um learns from the data, right? It supervises itself. It gets the labels from the data. So that's generative model, right? So what they do is that they try to learn the distribution of data, right? And use that to generate data on its own, right? It's a whole probability stuff, right? There'll be a lot of mathematics behind that, but it's it's not something you need to know, right? Because to go forward. Uh, you can just know all of this and it's good enough. In your private time, you can, go on and read naive days and all of that, and you get what you need to know. So yeah, now we're going to language models. So language models are just right. You have maybe a sentence, and you want to predict, like let's say I am a boy. Okay, let me say I am A, right? And you have a dash next to it. So what the language model will do is to try to predict what the next token in that sentence will be. So it can be I am a boy, I am a girl, I am a this, I am a that. But you can say you can now what the language will do is that it will use what it has seen before. Let's say I am A. Before I am A is my name is Mr. Nemeka, right? So if I say I am A, right, the most suitable words it should produce is man, boy, gentleman, all of that. So what a language model does is that it has a whole lot of tokens, right? It has a lot of tokens, right? And it is not a probability distribution, and it wants to sample the one with the highest probability, right? It's going to sample all of that. So it's statistical. Right? That's why they put the statistical model in front of it. So in depth, there's a whole lot of statistics, but it works, right? It works, and there's a reason for that. And we will cover that. We'll cover some of that in detail, maybe in the next course, sorry, not the next course, in the next session about embeddings and embeddings, tokenization, and the attention. I will try to cover the attention mechanism by the next session. That's very, very important. That would be very nice to know. Let me see if there are any other questions. Okay, is this a live conversation introduction to Python, or is it for Gen? Is Gen AI track? You most likely the introduction to Python for machine learning is after this one, right? It's by 5 p.m. to 6 p.m. So I think you should Nixon, is it Nixon? I'm saying Nixon, you have to wait for that. All right, yeah. Okay. On to the next. So now we now have the whole AI, what's AI or AI, right? So AI it's a whole field, right? You can say um deep learning is under AI when you are using it to create agents, right? You might say AI is a big field. I should have put a kind of a graph here or a figure to explain, but I'll put that in a slide before I give it to you. That'll be better. So AI is all about like building intelligent agents capable of reasoning, learning, autonomous, something that you don't need to control, right? And right, this little building blocks like deep learning, right? You see deep learning as a subfield in AI. Right? They use deep learning for AI, right? They use language models in AI. They use generative models in AI, right? So all of these all work together to build an intelligent agent. You see reinforcement learning in under AI, right? They are all tools of subfields of AI, right? To get to that intelligence agent sort of thing, right? AI, all those things we watched in sci-fi movies. So all of these are used to do that. And so when you hear Gen AI, you know that it's generative models used in AI, it's used for AI and all of that. There are a whole lot. And generative models should not only be text, right? Generate images, generate text, generate videos, all of that, right? So that's what all of that is. And if you have any questions, please do put that into the chat. So now, next thing, we'll also talk about NLP because I think our focus for this stage or most of the applications will be in NLP because um, whatever you learn in NLP can be used in computer vision. They are all intertwined, but we know for a fact that most of the advancements, right, the whole attention mechanism that brought up the transformers, that brought up the GPT, the BERT, they were all from NLP. They're all development in the NLP field, right? So why won't it be good enough to use that, right? Because all the attention mechanism was then adapted to the computer vision field, like the VIT, vision transformers, and all of that. We will not cover that in this because that is pretty advanced. But if you want to learn, you could just search on the vision transformer or the attention. But if going towards the vision transformer, like I see they are jumping where I needed. So when you get the hang of the attention mechanism, right, transformers, then you can go into the vision transformer and all of that. All right, let's continue. So NLP, we have all in one way or the other worked with NLP or in NLP, right? Building chatbots, we have interacted with chatbots, we have done with language translation. Google Translate. How do you use Google Translate? It's NLP. Question answering. How can GPT or ChatGPT know that you need to answer this question with this or all of that? Sentiment analysis too. All of that. So anything is just, like I said, it's a subfield of AI, like trying to get your computer to understand human language. Right? That's just what it is. They want it because if you want to get to that field of AI, right, you want your computer to understand what you type, limited to token predictions. Under the hood, it just predicts tokens, man. That is your thing. Under the hood, it predicts tokens, right? It's not that it's limited. It's that you get to see, should I take this question? I'll answer all questions after this session, please, so that this session doesn't get too long. I know Isodema was one that asks the mathematics stuff. All right, so yeah, that's NLP, and there are a whole lot of applications, like I've said. The one of the applications is machine translation, speed ASR, automatic speech recognition, text generation that you use to get your project and your SOPs ready and whatnot, like GPT. Yeah. So we also use anything in GPT and question answering, something that we'll see further in this course when we go into something called RAG, or retrieval augmented generation. So, like now, for instance, a chatbot, you want you want to build a chatbot for your company, and um, that chatbot should be specific about like to your company. Like you should use documents from your company, answer questions about your company, nothing else. So how can you build something like that? That's where question answering. So there's a whole field under it now. There's the RAG, there's AI agents and all of that. So yeah, the field has really, really advanced from just transformers in 2017. So these are the applications, and we will try out all of these applications using in the hands-on sessions for this stage. I'm sure some of you have seen a hands-on session, right? I think there was something about question answering and all of that. If not in this session, in this stage, in the next stage too. Sorry about all of the theory you have to go through in stage A, but that's just for stage A. Stage A has to do with a lot of understanding theory, so you know what is happening in stage B and stage C and stage D, and not run away from us. Right. So thank you. So yeah, the large language model, the whole LLM hype, it was all derived from the transformer architecture. Right? I think in the slide, let me escape from this. There is a whole image about this. The basic, right? This is the first, let me say, the basic transformer architecture. This is how it's on. Sorry, brother. Okay. This is how the transformer is before it was modified. There are a lot of modifications on it. There are a lot of layers to it, right? People add some, there's a lot of research, so they find out some of this is not needed, some of this is needed, and that's how the other kind of GPTs are or GPT 1, 2, 3. There's beds, there's fin bed, there's all of that bed, there's robots, there's all of that. So they all, people do research and find out that, okay, this is better than this, and they build their model and they release it for you to use. So yeah. So it all started from transformer architecture, right? The transformer architecture, and like I said, that is the transformer architecture, the basic transformer architecture that was brought up from the paper, right? And so what are large language models? Like in general sense, right? These models are built to just understand human language, right? They are built to understand human language. And in human language, there's code, there's conversations, there's chat, and there's a whole lot. There's the Wikipedia. So um language models are trained, I would say pre-trained on large text data sets, right? To understand. Let me do this. Let me do that now. So I don't. Yeah, pre-trained. Um, and we'll explain what pre-training is in stage. So in the second lab, right, for you. And we'll look at it, right? We will not actually do the pre-training because pre-training is done by large like companies, like you know about OpenAI, you know about Facebook, Google. You can do something like a mini GPT and do some pre-training, but you need a GPU, you need lots of GPU or a very large GPU, 32 gig RAM and all of that to hold all of the parameters that we use in pre-training. So pre-training is not, that's why this LLM thing is mostly done by big companies that have all of the resources and compute to do all of that. If you search on the time it took to train GPT-3 or GPT-2, you know that it's a whole thing. So um so pre-training it will be explained in next session, but let's just build like sequentially. Let's not go ahead of ourselves. So let's go. So LLMs can now, because they are pre-trained to understand language, right? Just like you can think of it like maybe the human brain. As we grow, we are learning, we are learning, we are learning. So what is now done, right, is that you have an LLM, a model that has like basic understanding of language, of English language. Like it knows basic understanding like verbs and all of that. That's just general like understanding, right? It understands language, and now you want to use it for a specific task. That's when fine tuning comes in, transfer learning, and I'm hoping that we all know what transfer learning is from deep learning, from computer vision, right? You have these, the concept was brought on from there actually, right? You have this big model that was trained by people like in the ImageNet. There was this competition ImageNet, and there are all these architectures like VGGs and the ResNets and all of that with their large parameters, right? And now you just want for your own use case to I'm sorry, I wish there were images, but I hope like from my explanation you can get what I mean, right? Yeah, you have this large model, right? And now for your use cases, maybe say you have 100 images or 1,000 images, and maybe the specific things the image you want to classify, maybe bottles in on the streets, right? So you don't want to go on and build your own large computer vision model. So what you do instead is that you have these models trained by people already. You download their model, their parameters, and pre-train from there, like transfer or do transferring or fine-tune from there, right? You cut off some of the parameters and learn those parameters again for your own use case, right? I hope you have, like I said, this is assuming that you have understanding of deep learning and machine learning. I see a question. I will answer the question by, okay, it says we understand. Udo, thank you very much. Thank you so much. I'll try my best to explain. Okay. Oh, this thing go now. Right. I need to go. All right. So where am I? So we've seen a whole lot of like applications. I know many of us here want to learn how to build stuff with this, right? We want to learn how to build actual applications with this, and there's a whole lot in the AI field, right? There's a whole lot of opportunities out there. There are AI engineers, LLM engineers. There are now LLM scientists, that do the research and build these models. And they're also, even in the ML field, in the machine learning field, right? You see many companies looking into building all of this. All right, so there are a lot of applications. One of them you actually try to build in stage E. You build a RAG enabled chatbot. You actually get the chance to see live, like real life example, real life project, right? That's the actual end of it. So um there are a lot of applications of LLMs in building chatbots, virtual assistants, even in healthcare. I'm not an LLM scientist. I don't know how they do the drug discovery, right? But there are a whole lot of kind of LLMs. I encourage you guys to check out Hugging Faces, um, Hugging Faces side and see a whole lot of models, a whole lot of fields, image. There are a whole lot of models and you can build a whole lot of things with them, right? And they all have applications. That. There's also particular for I think there was so if you are looking to explore a whole lot of things, you can also go to something called Papers with Code. So Papers with Code is where you get a whole lot of different models that do a lot of things published by um, crazy researchers out there, right? With a whole lot of methods that they are researching on, right? And yeah, so these are some of the things that you see as you have a build more in good in depth into the field. There's a whole lot of research, there's a whole lot of like this is the in thing, right? Generative AI, and I hope to see you guys at the last stage, hopefully. Yeah, and let's go on to the slides. Okay, I see some questions. Should we consider test like that sample generative task? Okay, I'd like to know if the next question the teachers, but we'll have more. Oh, okay, for read one, like I said, the next stages will be hands-on, and also the lessons will be hands-on, right? I'll be building more. I'll be teaching you, like, getting into code about what's going on in transformers. So that's what I'll be doing. And Uzodima, should we consider first classification and segment analysis in GPI tasks? If you saw what I was saying in the previous slide, text classification, question answering, and all of that, sentiment analysis are all NLP tasks. You want to understand language. Those are NLP tasks, but you use generative AI, you use LLMs in solving them. We found out that because they understood language, right? Because they understand language, they are now able to be better at this, right? Instead of using, LSTMs, RNNs, question and bet, right? There are these bet models before modern LLMs came into place. So we found out that because they understand language, it's better to use them, right? So it's not those are not generative AI tasks, those are NLP tasks, right? I hope that clarifies all of that. Also, yeah, we also have some applications in finance. it's a whole different ballgame when you can use this to make money. And we see that, there's some in trading, forex trading, stock trading, and there are some companies like quants, dev, and all of that. You see that they want to use computers to trade, right, instead of using humans. So you see, another application of this is sentiment analysis of financial news. Is this financial news good or is it bad? Is it something should I buy? Should I sell? Is it going to move the market up or down? So that's an application of the LLMs. So let's move on. It's another question. All right. You're welcome. So like I said, the characteristics of LLM, there's the original transformer architecture, right? The first GPT, there was the first BERT. They all were all based on the transformer architecture. The transformer architecture was a really big thing. It was a big paper, and I'll also share resources on where the paper is if you want to look at it yourself and understand what is there. So there's a sequence to sequence model, right? And there was the encoder and there was the decoder, right? And the encoder, um, there's the encoder and there's the decoder, as you can see on the text. And all of these had what do you call it? They all had like purposes. And you see that as time went on, people were like, um, they found out that this was quite big. It was too big, right? It had a whole lot of things going on. So what they did was that they splitted it. They now just use the encoder this side, and some people just use the decoder this side. I hope we can see the images I'm showing you, right? And we found out that this wasn't fast enough, and this is how all of every other thing came about, right? There was the encoder, and one example of a model built on the encoder was the BERT model. The full meaning of BERT is bidirectional encoder representation, the representation, actually, that's just it. So it was built on just the encoders, and they were like all of these tasks that it was good on, like it was better at some things, right? And now is now the decoder part, and that was actually GPT. Forgetting the full meaning of generative pre-trained think pre-trained model. I don't know what that T means. Okay, transformer. Oh, see, sorry. GPT, generative pre-trained transformer. That's what it means. And they are mostly decoder models, right? And it's specialized in text generation. If the first generation of GPT, that is GPT 1 and 2, we found out that they were good at text generation. Like, so you can do something like text completion. You say you type in something I have, and you see GPT continuing that text before, there's no paper. Like, so the truth is that after GPT-4, we don't know what OpenAI did. Right? There was no paper on GPT-4, even though people try to think about what they did, right? They try to build close relative to GPT-4 and make it open source for us to use. But there was not like a specialized paper released on what's at the in of GPT-4. But we know up to GPT-3. And, as you go in the field, I can encourage you to, go and read this paper if you have time. Nobody's really going to ask you what these papers are, what they do. They just want you to build something with it, depending on what you are actually. If you're an engineer like me, you not really bother, right, too much about what's going on in depth, like too much, right? So that's I see question is okay, regressive model, the efficient models, okay? We do. Can we use better generate and then the same as we use bag of words and what to bake? All right. We can use BERT models to generate embeddings, and there's a whole different package for that, and I will show you in the course too. We'll cover concepts on encoder decoder, yes. Variational and autoencoders, those are outdated though. Nobody use GANs again. Autoregressive models are GPT. The efficient models are computer vision related. So, like I said, we'll focus more on NLP models, right? If you want to do that, yeah, you can do that, and yeah, you can also, because we are looking for, like I said, we're looking for volunteers, right? And you could also be a volunteer and teach us diffusion models if you can, right? So yeah, we will cover some of these encoder decoder. Relation into autoencoders, no, we will not do that. Autoregressive, yeah, we will cover that. And diffusion models, no. So thank you for your questions. You can keep them coming. So the transformer architecture has some kind of like you have some components, right? There are many like enhancing components that were added and some things that were removed, right? In the whole transformer architecture, right? There's a whole lot added and removed in this architecture just for performance sake. And some of them will not be covered. I'll also share resources for you to read in preparation of what I will teach in the next live coding session. Please do try your best to read because I'll be doing um some code, right? I'll running some code and I expect you to understand since we are all desirous of what's going on in depth. So the transformers were now like used, right? The original transformer architecture was now used to build the modern LLMs that we see, like the BERT and the GPT and all of that. So, like I've been saying, the transformer architecture was the beginning, right? It was just the first stage. A whole lot has changed from 2017 to 2024. That was 7 years ago. So we expect a whole lot. And it's not easy keeping track. And I don't know if you as human beings, anyone can just keep track with what's going on in the AI field and in the NLP field. There's a whole lot going on there. And I wish you good luck if you want to try to keep up. There's a whole lot of papers out there. And I also showed like a whole lot of models out there. A lot of them, Whisper, we know Whisper, there are a whole lot. Mistral, there's a whole lot. So it's not easy to keep. You just want to know what works for you, what's good for you, right? And um that's what's important actually. Just know what's the basics and you can build from there. You can know what's going on in your own use case. So let's go on to the slide. I'll also be taking more questions if there are any. Just why are many students joining this time? Okay. So I see one more question. Can we combine custom decoders alongside best information translation? Can we combine custom decoders? Um, Zadima, I see your questions. Okay. I can't hear anything. I'm not talking. Question. Custom decoders alongside best. There have been actual models that are combinations of the encoders and the decoders. There's a whole lot of people joining in. Why though? Wait, let me just start about. So yeah, Uzodima, there's something called the T5 model, and it's also in the material. If you read it, there's a T5 model, and the T5 model is a combination of the encoder and the decoder, and it's specifically for what you said for machine translation. Even though you can also use the BERT model for translation, but the whole essence of other models on other models is that they found out that this model is better than this one, so let's use that one. So if you go on Hugging Face and search for machine translation, or sorry, human translation, and you see like models that are very, very good at translation. You see there's the T5, like I said, there's the T5 model. T5 model has the encoder and the decoder, and it's also in your material. Please try to read the material before every class, so I don't go about repeating all of that. So there's T5 and there's Facebook and LLB model. So these are like what's trending in the translation field, right? There's Opus, there's T5 small. All of these models have different sizes. There's the big, there's large, there's big, there's small, and yeah, they all have their performances, their evaluation metrics, their scores, and that's why it's in the material. So when you read the material and you see some names and you go on Hugging Face and you see something like this, you know what it means and not wonder what's T5, what's this and what's that. Yeah, so let's continue where we are. slide. Okay, there's another question. All right, you're welcome. Dima is asking some serious questions. He really wants to be an AI engineer. All right, so what we'll cover um in the next session, actually, the next session will be embeddings, right? We'll also like run code on how the embeddings are generated, or we'll use already existing code, right, to run embeddings. So if you're familiar with what to vec, you should know what embeddings are. So before the introduction of bets and all of that, there was a word to vec, and word to vec is like converting words, right, words and or sentences to vectors, and these vectors are like mathematical, just like how vectors like the in linear algebra, you know what vectors are, right? So vectors are like um mappings in space, right? You know what vectors are: 3D space, 2D space, 4D, whatever. And so what this helps us do is that it helps us like calculate similarities, or is this word close to this word? Is this sentence close to this sentence? We will also see that in the material, and it's also present in the material too. Tokenization is like you know, computers don't understand sentences. What they work with is numbers, right? So what we do is that we break a word, like a sentence, let's say I am a boy, into tokens. And because of that, like now, the ing part of it, right? What's going to happen when there's he is going, or is go, can he go? So all that things. So tokenization, there are also like models trained to on how to split text, right? That will be sent used to train the model, because traditionally computer doesn't understand text, so it uses numbers. So this sentence is broken down into smaller tokens, and those tokens are converted to numbers, and they are now used as inputs in the model. Okay, I see a lot of people are joining in. I did for this course or for the mathematics course, we'll find out later. All right. Oh, this data science session. It's not data science session. So this is the Gen AI session. I don't know if the wrong link was shared with you. The data science will start at 5 p.m. This is 4:41. We still have 20 minutes left. So you have to wait for that session. When it starts, you get access to that. All right. So sorry about that. So sorry about that. Yeah. Thanks. No wonder there was an influx of people in. I was like, are these all people looking to learn Gen AI? All right, so let's continue. So the whole hype behind the LLM is actually the attention model. And also in the next session, I'll try my best to explain the attention, some of what's the mathematics going on in attention. But from the word attention, you know that's just like attention, right? Before the time of attention, there were the LSTMs and RNNs, and they were working. But if you do some, like, why was the attention brought about? The attention was brought about because you couldn't scale up RNNs, you couldn't scale up LSTMs, right? You couldn't do them in parallel, or because the LSTM RNN were sequential. As the words were coming in, it was going to do the mathematics. So I am a boy, going to put I first, then am, then A. So, but attention brought about something that could be scaled in parallel and all that. We will see all of that in the next session. But the attention was the key part of the transformer. It was the key part for the whole advancement in the field. Right? Attention is all you need. If you can search for this paper, attention is all you need, right? It's the paper that brought about the change in NLP field, actually, 2017. So this was where it all started. The whole hype of LLMs, where it all started. So it was a research paper by Google. His phone has his own Wikipedia page, right? So all of that. So this is where the whole lot of it started in NLP field. So yeah, if you when you are done with this, you can also check that out. I also share resources in preparation of the next session we'll have, right? I'm not going to invite all of these people yet. Okay. So yeah, and also one other thing is the pre-training. So if you remember the material, you have seen something called pre-training. So there are a lot of pre-training tasks, right? There's next sentence prediction, there's the masking. So all of this during the early stages of the BERT and GPT. So there were these pre-training tasks, right? These pre-training tasks that were carried out with large corpus of text, right? So if you search what was BERT trained on, BERT was GPT or BERT was pre-trained on pre-training, sorry. BERT was pre-trained on I think Wikipedia and I think you just need to search a paper. If you want look at one of these papers, you see like Bet was portrayed on Wikipedia and some other text data too. So what it does is that they either they mask out some things and ask the model to find a way to predict what that word would be. So there's a training process, there's a loss function, there's the what's the word, the optimizer model, and a whole lot of there's a whole lot of that there. There's the metrics that are used to guide the training, whether it's getting better or not. So all of this will be talked about in the next session. Just wanted this to be an introduction. So when we talk about all of this, we are not asking me questions about these things only. I expect you like to know and understand some of the things I'm going to be talking about. So yeah, um now the slide is in the slides I also give you some resources for you to see a visual and intuitive explanation of the transformer model. This is by J. Alama. J. Alama is a very, very popular um, figure in the NLP and think about that before. In the NLP and generative AI field, right? He went down to a lot in depth about all of what's going on in the transformer. And we'll try our best to cover this in code, right? I will try my best to cover this in code in the next session and run code and see what's happening here. But I will encourage you to look at this, right? Look at this and try it, like not try it out, read it, the high level, right? The high level overview of what's going on. There's also a YouTube video where he explains it. So yeah, that will be most likely all for this session. There's also the illustrated GPT-2, right? It's focused on GPT architecture that was used to build the GPT-2, 3, 4, and also the Llama 2, and all of the other llamas that you have out there. So please, if you have any questions, now is a good time to ask. I think this is the end for this session for today. Please, um, okay, let me go back to the top. I'm wondering why we don't have lots of hands-on sections in the materials. Now, I'm also saying this again. This stage A is for building fundamentals. You can't be running code when you don't know what's happening in the code. And also in stage B, there'll be a whole lot of code there. There's a whole lot of frameworks to introduce the Hugging Face framework for you. When we introduce calling the models and using the models for actual tasks. But I see that many of you here are jumping. You want to jump to one thing and lose from foundations. I don't know what's going on there. So that's why there is the introduction. I don't see why you want to go to stage B and not know what's happening in stage A. But I hope this explains it. So is Gen AI creating Gen AIs and working with LLM? Gen AI is creating Gen AI and also working with LLM. But because of resources, we are not going to be creating Gen AIs because, like I've been saying, Gen AI, LLMs are very, very expensive to build. If you have funding or you're a research group with funding, you can go ahead and build your LLM. And this course will give you the necessary details you need to at least build an LLM, right? But what we'll be focusing on will be using LLMs to build actual applications, right? We'll be working with LLMs, optimize LLMs, fine-tuning LLMs, and using LLMs to build applications, real applications. So that will be the main focus. But if you want to build your own LLM, you are fine. You have necessary information to do that too, right? So are there any other questions? Right. I see there's no other question from me. So because of the next session I'll be going on, you'll be given access to who's that dim? Okay, so we will be given access to remote GPU to fine-tune our models. You will not be given access to remote GPUs to fine-tune your models. Please, that will not be given to you. You all, if you have, you can get like credits from maybe all of these cloud services like AWS, Azure, and Google Cloud if you want your own remote GPU. There's also Google Colab we'll be using extensively in this course, right? We're using Google Colab extensively in this course to do our model building, model training, right? Not model building, our model training and fine tuning. We're using we're using Google Colab for all of that. Okay. Bruno is asking to build applications like, all right. So like I said in the slide, there are a lot of applications, and the one we build will be something like a chatbot that answers questions based on your documents, right? You have some documents and you want to ask those document questions, RAG, right? You can also um augment it, right? Make it better use it to build a chatbot for your own use case, right? That you're also welcome to that. But we'll build a custom RAG chatbot. Will I say a chatbot? Yes, for asking questions about your particular document. We'll be going through all of the steps for that. Right. So if you're not patient enough, yeah, so you have to be patient to get to that. That's how courses are. Don't run, right? Is there any difference between hidden states and context vectors? Okay. And is there any difference between fine-tuning and transfer learning? Fine-tuning and transfer learning can be used interchangeably, right? And that's the deep learning question. What we'll be teaching here is to fine-tune LLM models. We also show you how to fine-tune custom LLM models like OpenAI's right? And we also show you how to fine-tune open source models like what we'll be showing you is how to fine-tune Mistral. Mistral is an open source model. You can search on Mistral over here at Hugging Faces. Get this out. Let me search for Mistral. So Mistral is also a powerful model, and the good thing is that it's open source. So it's almost like GPT. We even know the difference between open source and closed source. Open source is models that you can download and use on your own. Closed source is something like GPT that you don't have access to, right? You don't know what's going on. You can't really handle it on your own. So that's the difference. So we're going to show you how to do the fine tuning of open source models and also closed source models. And that'll be in stage 3, so stage C. So just be patient enough, follow through, get the basics right, and you move on to the next two. So is there any difference between hidden state and context vectors? That's deep learning. Context vectors most likely used in LSTMs and RNNs, and they are most likely almost outdated now. Hidden states are used in neural networks, feed-forward neural networks, and also CNNs and all that. So you can always ask Google to Google, and I'm also assuming that you have basic knowledge on deep learning. These are deep learning questions. I expect you to have some experience with that. Is GenAI beginner friendly? Is GenAI beginner friendly? I know that when this course was sent out, when the notification was sent out, it was told to you because you are Hamoye fellows, right? So we expect you to have some basic knowledge of machine learning, deep learning, because for you to be Hamoye fellows, you should have done data science track or data engineering track and one of that. And so you should have some basic knowledge of all of that. So we will not be going back to those things. We expect you to know some of them, but the course is also explanatory enough. So that's why it's bulky, to explain every concept as time goes. I know it's bulky, but just bear with us. This is just the first stage. Second stage is not as bulky as this, and there's a whole lot of code. So yes, it's beginner friendly, but we expect you to have some prerequisite knowledge to go on. All right. So I think because for the next session I'll be going, I think it'll be the last question I'll handle for today. If you have any questions, please type it on Slack. I'm available on Slack to answer any questions. Um, thank you very much for joining us today, and yeah, happy learning, good luck learning, and I hope to see you in the next session. That'll be on Monday. Thank you. All right. So if you're not for the introduction to machine learning, Python and machine learning, please leave the meeting. So we're done here. This link we use for the next session. So all right.